This is part 2 of our introduction to C++. In this particular element of it, we're going to introduce and talk about the notion of C++ being a compiled language. As mentioned, C++, it is a compiled language, and we're in classifying it as such, differentiating it to some degree from some other languages, in our case most notably Java or C#, which nowadays are incrementally compiled. Going back up to the earlier versions of Java, it was more interpreted, and there and still are some Java interpreters out there. We will be looking at the whole process of compilation and the different stages and what happens and things like optimization in more detail. But at this point, we're just simply introducing and saying what it is by way of this being a compiled language. When we go through the steps, there actually are several of them that form the process of compilation. And by compilation, we mean taking our source code and converting and forming and shaping it into an executable file that can then be run, can be executed. So several different stages to this. In a lot of environments, say with your IDE, you can sort of type in your code, you can hit your run, and that's it. It magically runs. What happens behind the scenes in a lot of these IDEs, there are several discrete stages that occur. In C++, you actually have a lot of control. All these, most languages, they are sort of completely separately defined. But in C++, you do have a lot of control as to how you can configure and interact and manipulate with the different stages. And quite often the error messages that are produced, they will direct you to one of the stages where, if you have an error, where that error arose in. So the first phase here is actually creating our source code, or sort of our text-based code. And in CPP, or in C++, there's two types of source code files that you will end up generating. One are your CPP files, your C++, and the other then are your header files. And we'll have a look at both of those, and we'll be writing them within, in our case, Visual Studio. The second phase, this is the really sort of the start of the process, the full compilation process, is actually a pre-processing stage. And this happens before compilation proper begins. And effectively, there is a preprocessor that searches through your .h, your header files, and your CPP files, and looking for preprocessor directives. Now, normally these are things that begin with a hash. So, for example, hash include, hash not defined, and so on. And actually, you get those types of directives in Java and C# as well. Whenever the preprocessor encounters a directive, it then processes and considers that directive, and that can end up in the source code actually changing. So it can insert things, it can remove pieces off it, and that's quite common for a lot of languages. So preprocessing, second phase, is if you like, the first conversion phase that brings us along the compilation process. After we pre-process it, we then enter compilation proper. And the whole purpose behind compilation is to take our text-based source files and to convert them into something that is executable or nearly executable in some sense. You're down at either machine code, or it could be for a virtual machine, it could be a real machine, or object code, but something that is very much low level and is very close to being executable. For C++, each of our CPP files, they're the things that get to be compiled, and for every CPP file, a corresponding object file, an OBJ file, is created, and that's the output of the compilation. Phase 4, this happens after compilation, so every single CPP file has been turned into an object file. They're independent standalone files, not yet an executable at this point. So the process of linking takes all of these different object files, and if you reference third-party libraries, takes their object files as well, and packages them all up together into a single executable. And I'll also add in a little bit of a loading code at the start of that to load in your executable. Whenever linking has finished, the output from linking, depending on what you're building, but if you're building executable, then it is actually an executable itself. So effectively at that point, we have something that is runnable. Two phases after that, phase 5 is loading, phase 6 is execution, and this ties into the notion that whenever you run an executable, there is actually a small program, a loader, that, if you like, another program that runs first of all, that brings your executable into memory. And then once it's done that, once it's been loaded, you can start executing and performing whatever code it is you want your program to perform. So that's the steps. We'll be looking at each of them in more detail when we go on to look at compilation, the process proper. Only one thing to flag up here, which actually is quite a useful component of it. It's quite common to compile individual source files into object files. The benefit of this is that if I have a large project and I then change one of my source files, I don't have to go and compile every other file. I just need to compile the things that I've changed to produce new object code for those, and then to relink it together into an executable. So it's an efficient way of actually managing a large project. In some projects, actually probably most projects, it's not that sensitive, the order in which things are compiled or linked together. But actually there are a number of other projects in which it is quite important to build and to compile and link things in a specific defined order. So in C++, actually in most other languages as well, you have a make-file or a build script, and it gets to determine the order in which these things are added together. So we'll having a look at those as well. So overall, just by way of summary, C++ is a compiled language. We give a very brief overview of the different steps that this involves, taking source, turning it into an executable. They're all quite accessible and all quite configurable within C++.